Welcome back to Chapter 4. In this chapter, we're going to be looking at understanding and comparing distributions. Now, we'll be comparing some distributions. It could be two different populations, or being able to split up one population into different pieces and looking at that. We saw this a bit in Chapter 2 with categorical variables, but now we're going to be including quantitative variables as well. So our learning targets for today, we can interpret and compare given displays of distributions. We can create appropriate displays of data and compare distributions. We can interpret and compare given summary statistics of distributions, and we can evaluate the effects of re-expressing data. And that's going to be an intro type topic. So in this, generally speaking, I don't like to use the same examples that the book does, but the one they had going for this chapter was really, really good. And so I wanted to highlight some of that. Now, that doesn't mean that this is going to replace actually reading it, because there's a lot more detail there, but just some little things. So we're going to start out with just the data. It's the average wind speed um, for any given day, and in a place. I can't remember exactly what it was, but it was some woods or something. I think it was in the Northeast. And so we have this distribution that we have a histogram and we have a box and whisker plot. So with the histogram, we can see that it is skewed to the right because our tail's going there. We can't necessarily tell if there's any outliers from the histogram, though. We, if we look at the box and whisker plot, we can see that. Um, the center with the box and whisker plot, we see that the median is right there, right about 2, which we also get from our summary data. The mean is going to be a little bit higher than that just because it's skewed. And so there we can see the two different things. This is what you did last week. You made a histogram and a box and whisker plot for the same thing. What's nice about this is notice that they're on the same x-axis. The x-axis there is the same, so we can really use these two things to compare. So this is overall for the year, the wind speeds. Well, different times of year could have different wind speeds. So if we broke this out by season, we could have this fall, spring, summer, and winter season. So here we're comparing the different wind speeds with also a categorical variable. The winter, spring, summer, and fall is a categorical variable that we just split these out on. If we had two, just two categorical variables, we could look at these as back-to-back histograms, or sometimes we do one on top and one on bottom. So it just goes underneath. It starts with the same x-axis and then just goes the other direction. But with 4, we'd need to split it out. So now this one, it took this one population, split it out into the season, which you could do. You could also take different populations. Let's say we wanted to find some information out about the students at Stanwood. We could have them split into freshmen, sophomore, junior, seniors. We could have them split into boys and girls. We could have them split, we could split it out over whatever categorical variables we wanted to, if we thought that that was going to show a change in the distribution to allow us to compare what was going on. A couple things to notice here is notice the x-axis for all of these are the same. We're always going 0 to 7 in the exact same distance even, right? It hits 7 at the same time. So the x-axis is the same, but also the y-axis is the same. It goes up to 50, even though only this one actually gets up to 50. Most of them stop short, but it doesn't change the axis, which would make the bars look taller. It keeps them all the same. We could do almost the same thing with one graph and just different colors like overlaid, but that would just be confusing. But that's kind of what we're doing here. We just have them all split out so that we can see each of them individually. Um, and so when we're looking at these, we can see that 3 of the 4 are kind of like the overall. A little bit less skewed, but they're kind of the overall. However, the summer one is, the variability is way down. We had way less variability in the summer. We could look at box and whisker plots below, just like we did for the top one. We didn't in this case, but we could. And so that's one way that we can compare things in the distribution and kind of understand what's happening. It's like fall, spring, and winter, it's all about the same. But summer, we have a lot of days with just a little bit of wind. Another way of looking at comparing data is to look at the box and whisker plots only. So we could have it broken out just like we did here into the 4, or we could break it out into months. Now the cool thing about breaking it out into months like this, so each month has its own spread of data. It has its own median, it has its own interquartile range and its own box and whisker plot. And what we can see following this is that if we're looking at kind of like the average wind speeds, it is going to kind of be cyclical. It goes up and it goes down. The higher wind speeds are going to be in the March area. The lower wind speeds are going to be in August. Now that's the average wind speeds. Notice the minimum is about the same. Every month there were days with very little wind. The maximum definitely changes because in like March and April and such, you have outliers even up at the top. But then in summer, like in these months, you don't have any days that have much wind. Notice in this box and whisker plot, by the way, our categorical variable that we're splitting it out, the month, is in the x-axis, and our average wind speed was now in the y-axis. So we don't have the frequency anymore, but that's where the box and whisker plots go. Remember, the nice thing about box and whisker plots is it's only a one variable thing. Like the histogram has our variable and frequency. Box and whisker plots don't. It's only the x-axis that gets labeled. Or in this case, it's only the y-axis. And then we have a whole bunch of different samples, which are the months. So we can see that there is a seasonal cycle to this. And looking at the box and whisker plots for each month can be nice because it summarizes it. It gives us a better look at it as opposed to just having all the data points, which can get a little bit it can get a little bit not confusing, but a little bit overwhelming to have all the data points. This allows us to kind of find the middle of each of the months, and so I was able to roughly and not particularly accurately kind of sketch what the average wind speed is going to be for the year. And it makes this kind of sine curve, which when we're talking about like natural things happening over a year, a lot of times it does make something that looks a lot like a sine curve because it changes seasonally. If we did want to look at every single data point, it looks kind of like that, where we can see that, I should probably change colors here, we can see that there's a lot more variability there and there, which correspond to the 3 months that has a lot of variability. Where in the summertime, the variability is really short, really small. And so it helps to show what we've seen, but as you can see, there's a lot of data here. The book uses this, and they run some simulations where they just kind of reorder it to see if this is a freak thing, or if it just, or if it might mean something. And when they reorder it, they never get anything that looks anything like this. Like the summer is all spread out, so you don't have that lull in the wind speeds like we see. So that means that there's probably something to the low wind speeds in the summer. It wasn't just random. When we are dealing with time plots, it gets tempting to make predictions for the future. Now, with something like this, chances are, yeah, it's going to continue kind of the same. Like, might we have a really calm winter or a really windy summer? That's possible, but more than likely, it's going to continue along the same patterns. Not everything does that. There are things like pretty much anything that's not a natural system has so many variables acting on it that it's really hard to make good, accurate predictions for the future. Now, that doesn't mean that people don't try, but you just have to be very careful about that. I mean, we're in 2020. It's really hard to make any predictions about what's happening tomorrow, much less what's happening like a month from now. So the same's true for a lot of things. Re-expressing data. Now, re-expressing data, this is something we will get into a bit more when we're looking at the bivariate data, where we have two variables and making scatter plots. But what this is sometimes you have data that's skewed, that you would rather have more symmetric, so that you can like find the mean, find the median a little bit easier, sometimes comparing them. And so what you can do to re-express data is you could take the log of the data. If you take the log of the data, especially if you have varying spreads, like varying ranges, that will help to equalize that a bit because of how logs work. Other things we can do, other than taking logs of data, we can take the square root of data. If it looks like it's increasing at kind of a squared thing, we take the square root of data. We could also square the data. It's another option, just to kind of get it so it's a little bit easier to work with. This is a fairly minimal part of this chapter, and again, we'll get back to it when we have two variables, but I just wanted to mention it here. So that's the rough outline of chapter 4. Definitely read through it. They bring up a lot of good points. They show you how to make stuff using your TI calculator. And I will see you in class. But until then, keep working problems, keep asking questions, and as always, happy mathing.